Step-by-step exam solution. Okay, physics class, training you to excel. Subscribe, like the video, share the video with your friends, alert so that you receive the next video. Please drop your comments. It will help me to serve you better. Tell me the next topic you think we should treat. It's very important. Okay, physics class. Present step to exam success. Step 1, pray. Step 2, plan. Step 3, prepare. Step 4, preview. Step 5, you perform. These are the 5 steps to excel in exam. In this present video, step-by-step exam solution presents simple harmonic motion, number 4 video. And here we are dealing with the oscillation of a simple pendulum. In this presentation, we'll be looking at oscillation of a simple pendulum. And under the oscillation of a simple pendulum, we'll be looking at the factors that affect the period of oscillation. And then we'll look at the graph we're going to get when you plot the graph of t squared against r. In the next video, video number 5, we'll be looking at oscillation of a mass attached to a spiral spring. Under that video, we'll be looking at these following topics. Then, in the last video, under this simple harmonic motion, we'll be looking at types of oscillation and resonance. When we come to that video, we'll be looking at these topics or subtopics. Now, let's go straight to the current presentation. The oscillation of simple pendulum. So now we start. The period of oscillation of a simple harmonic motion is given by, this is a popular formula we have already get used to since we started discussion on simple pendulum. It's given by T is equal to 2 pi over omega, where omega is the angular frequency or the angular speed. 2 pi is a constant, so the period of oscillation of any object oscillating either in a vertical oscillation or horizontal oscillation, the period of oscillation is given by this. Now, for a simple pendulum, there are some factors that affect the period of oscillation, and that's what we want to examine right now. What are those factors that affect the period of oscillation of a simple pendulum? Let's look at this animation to check. Here you have 3 simple pendulum. If you watch the animation, you see that they have different masses, but they have the same length. So we want to examine what's the effect of the mass or the bulb on the period of oscillation of a simple pendulum, or what is the effect of the length. Now, looking at this as it's oscillating, you will notice one thing. What is that? They have the same period. They perform the same motion, almost identical. The same period, move to the left at the same time and to the right at the same time. That shows that the period of oscillation of a simple pendulum does not depend on the mass or the bulb attached to the end. The length is constant, the mass varies, but the period is the same. So now, the period of oscillation of a simple pendulum is independent of the mass of the bulb. So that is very important, and I want you to take note of that. So number 2 we want to examine is, now that we have seen that different masses, the same length, has no change in the period, can we now consider the other side? What do we have here? The same mass, different lengths. What do you notice for this case? Do you notice any difference in the vibration or the oscillation? Yes. The one with the shorter length moves faster. In other words, the period is shorter. The one with the longest length is the one that moves with the lowest speed. In other words, the period is more. So we can see here that the period of oscillation of a simple pendulum depends on the length of the simple pendulum. The period depends on the length of the simple pendulum. That's one thing I want you to observe here. So, but before we continue, please like the video and share the video with your friends. So now we are going to see the shorter the length of the simple pendulum, the faster the oscillation. That is clearly seen. So therefore, mathematically, we can simply say that the square of angle of angular frequency is directly inversely proportional to the length. In other words, the speed is inversely proportional to the length. The shorter the length, the faster. The longer the length, the slower. So now that's how it happens. Now we're going to examine the next one. The next one we're going to have the same mass, the same length, but all displaced through different angle of displacement. So you see, the first one has larger angle of displacement from the rest position. The blue one has smaller, and then the red one has the smallest. Now, what do you notice when they have when we displace them through different angles? So now you discover that even though they oscillate and one appears to move faster than the other, but they still have the same period. What's our conclusion here? The period of oscillation does not depend on the displacement of the bulb from the rest position. But remember, for accuracy in experiment, we need to make the angle of displacement as small as possible. Very important for a better experimental result. The angular frequency or speed, omega, is given by omega is equal to what? Square root of G over L, where G is the acceleration due to gravity and L is the length of the simple pendulum. So yeah, but you know that the acceleration due to gravity is constant in a location. The length varies. So therefore, angular frequency depends on the length and is inversely proportional to the length. So now that's what we are saying. And now, having come to this, we can now simply say that the period T of oscillation of a simple pendulum is given by dividing is equal to 2 pi over omega. Remember, 2 pi over omega. But now we have established that omega is equal to this. Replacing that omega or the angular frequency with this, we have this. Simplifying further, we have the period of oscillation is given as 2 pi square root of L over G, showing that the period of oscillation is directly proportional to the square root of what? The length of the pendulum. So gravity in a particular location is a constant. So we can simply see that the period of oscillation is directly proportional to the length. Is directly proportional to the length. That is not equal sign. Directly proportional to the length. So now we're going to move to the next slide for the continuation of our discussion. So in this side of presentation now, we're going to look at the plot of T squared against L. What will it look like? The period of oscillation, as I said, is directly proportional to the square root of its length. That is, the period of oscillation increases as the length of the simple pendulum increases. T squared is directly proportional to L, where L is the length, T is the period of oscillation. Now, when we plot the graph of T squared against L, we're going to get a straight line that passes through the origin. That's why we say it's directly proportional. If there is an intercept, it's just proportional and not directly proportional. But when we say it's directly proportional, it's going to pass through the origin. Now let's look at the plot. Now we have the T squared on the vertical axis and L on the horizontal axis. Please take note, in practical physics, you must label the axis correctly with correct units. That is essential. You cannot afford to make mistake. So now, when we plot the graph, as I said, it's going to be a straight line that passes through the origin. So now, in every experiment in physics, we need to get the slope because the slope is very vital in answering question in that practical or in that experiment. So now to do that, I take a point, take my ruler, and then draw a line from that to this end. Then I now draw a vertical line to reach the red line again. So now let's see that. So we have that. So now that we have this, we can see that the slope here is given as S is equal to 4 pi squared over G. So that's this slope, meaning if I divide this vertical by the horizontal, remember vertical is T squared by the horizontal L. This is the slope, and that's what the slope represents. So now, having obtained the slope that is equal to 4 pi squared over G, now, what are the considerations we need to look at when we are handling this experiment in the laboratory or calculations in the class or as a homework? Number one consideration we need to look at is that the bulb should be displaced through small angles, as I said before. You should displace it through small angle. Large angle will still give you the same period, but it will come with a lot of errors. So if you want to get good results and plot a good graph and get something that will be close to a perfect graph, you should make the angle of displacement, the displacement from the rest position, the angle should be less than 30 degrees for a better experiment. So number two consideration we are going to look at is the slope, which we have seen here, is used in calculating the acceleration due to gravity. If I know the slope, so the only unknown here will be G, the acceleration due to gravity. So this slope is very essential in calculating the acceleration due to gravity in the local place where we perform the experiments. So please subscribe. So we move to the next slide to continue the presentation. So now let's do some calculations now. Let's start. Calculate the period of oscillation of a simple pendulum and the time it takes to complete 30 oscillations. The length of the pendulum is 0.9 meters and the acceleration due to gravity G is 10 meters per second, given that pi is equal to 3.142. So now let's solve this question now. So now we have, first in physics, as you know, you quote the formula, write down the formula, then go a step further, tell the examiner what T represents, tell the examiner what the L represents, also tell the examiner what G represents. That will give you a full mark for the formula. Please, that is very essential. You must do that in every calculation in physics. Then we now having quoted the formula and explaining the symbols, and now go ahead to say T would be equal to 2 pi. This is the value of pi given in the question. Please always use the value of pi given. Don't say, I know that pi is 22/7. You go ahead to use 22. It's not allowed. Then we're now going to the square root. The length is given as 0.9 meters. So we write that here, 0.9 meters divided by the gravity in that given, which is 10. Now that we have made correct substitution, so the first mark in marking calculation in physics is the formula with the symbols explained. Now number two is correct substitution into the formula. Then the third point the examiners will be looking for is the evaluation of this to get correct answer with unit. Now, if you take calculator and take 0.9 divided by 10, that will give you 0.09. Take the square root of that and multiply the square root of this by 3.142 and multiply that also by 2. If you do that very well with your calculator, you are going to see the answer you will get will be 1.8852. This is giving correct to 5 significant figures. And then we attach the unit. What's the unit of period of oscillation? Seconds. So now the full mark here will be 1 for the formula, 2 for the correct substitution into the formula, 3 is for the answer with correct unit. If your unit is wrong, you will lose the marks. So now we go to number 2. Number 2 question here says, and the length of the pendulum is this and this, and we're asked to calculate the period of oscillation of a simple pendulum. So now we have that T and the time to complete 30 oscillation now. 30 times the period 30 times the period. So that will give me, use calculator, work out this. If you do that, you are going to have 56.55 seconds. So therefore, the time to complete 30 oscillation would be 56.55 seconds. So now, having solved this, we take the next and the last example for this presentation. And that is, the period of oscillation of a simple pendulum is 1.8852 seconds. When the length is decreased by 20 centimeters, remember the original length is not given. And when this length is now decreased by 20 centimeters, that's what we usually do in experiment. After taking the first period, you will change the length. So when that length is decreased, so we have by 20 centimeters, the period of oscillation now is 1.6626. Now, say calculate the length of the pendulum. That's the initial length before we decrease the length by 20. G is given at 10 meters per second squared, and pi is given by 3.142. Now, let's go to the next slide to solve this question now. So let's solve it now. So now, we have the question there to guide us. So now, we quote the formula. As I said, quote the formula. That's the first thing you do. You quote the formula. Then please go ahead to tell us T is what? The period of oscillation. L is the length of the pendulum. G is acceleration due to gravity. And since we are looking for the length, so we make T the subject. For the first length, we are going to have the first length squared. The period for the first length is given by this. That's squaring this right-hand side. 4 pi squared L over G. Now, for the second one, the period of oscillation, when the length is decreased by 20 centimeters, will give us a L minus 20 over G. So we have two equations. So now, what we'll do now is, we are going to take the ratio of those two equations. And the ratio will say T1 over T2, it will be equal to the length we have on the right-hand side for the T1, then divide by the value of the T2. So now for T2, we still have that also. Now we have the ratio taken, the ratio of the left-hand side and the ratio of the right-hand side. So what do you notice here? Look at the right-hand side. This is common to the denominator and the numerator. So what do? We eliminate common factors. So having eliminated that, so what do we have any other common factor we can eliminate? Of course. Do you see this gravity and this? So we eliminate that. So we have that. Then T1 squared over T2 squared will be equal to, what is left here? We have L. And what is left here? L minus 20. So now, that gives us a very simple something now to handle. So we are now going to put the value of the two periods given to us. The first one is giving us 1.8852. Use your calculator, find the square of that. You have 3.5548. Then do the same thing for the second one. The period of the second one is given as 1.6626. Use your calculator, square that. If you square that, what do you have there in your calculator? If you have done it well, you have 2.7642. So you have 2.7642. That's on the left-hand side. On the right-hand side, we still have the same value. There should be no change. So now, then next we are going to do now is to simplify this expression. We simplify this by cross-multiplying. This will cross-multiply, and this will go ahead to multiply the other side. So I'm going to have that cross-multiplying. We are going to have 3.5540 times distributed into L minus 20 will be equal to, then cross-multiplying this will give me 2.7642 multiplied by L. So now, we are going to distribute 3.5540 into L and minus 20, or what the term we have in the bracket. So that will give me 3.5540 L. Then that give me, use your calculator, 3.5540 times 20. If you do that well, what will you get? If you have done it well, you discover that you are going to have 71.08. That's 71.08 will be equal to the right hand side. So now, what should we do next? We collect like terms. So now, collecting the terms in L together, this crossing the other side becomes minus. Then you have 2.7642 L. Then this minus going to the right hand side becomes plus. Then you have that. Then you subtract this. If you subtract correctly, you are going to have 0.7898 L will be equal to 71.08. So what do? We divide both sides, this side by 0.7898 and this side by 0.7898. So that will give me L will be equal to 71.08 divided by 0.7898. So now, use your calculator again, divide this. What do you have there? If you have done it very well, you are going to see that the answer there will be 89.997 centimeters. 89.997 centimeters. That will be the answer we are going to have. So now, that brings us to the end of, please subscribe to the channel, like the video, share this video with your friends, click the alert button so that when the next video is released, you will be alerted. That brings us to the end of this presentation. Thank you very much for watching.